All right, and we are live. Welcome everybody to this week's edition of Sunday Fun Day. We're joined by two very special guests today, Ricardo and Haruna, and we're just gonna go ahead and dive into the fascinating topic of manufacturing and open source. And without further ado, I'm gonna go ahead and jump right into it. But before we do, I'd like to just take a step back and say today's session is a non-sponsored session, and you can hear it from Ricardo and Haruna themselves, but we have not paid each other to be here. Nobody's getting any special incentives. And at the end, I will also share some links that you can check out to see some of the wonderful work that Ricardo is doing, as well as where you can find these two fine gentlemen. So, uh, without further ado, let's go ahead and introduce our panelists today. So, Ricardo, we'll go ahead and start with you, and then we'll jump over to Haruna. Take it away, please.
Hi, my name is Ricardo Olsen. I live in Brazil, here in the south of Brazil, Porto Alegre city. I am an electrical electronics engineer. I graduated here in Porto Alegre 1992 with a master degree in electronics instrumentation. And since then, I started as doing some research job in the university. Then next, I worked in the in the industry of building machinery for the leathering industry as an embedded systems developer, creating automation for the leather industry, like measurement tools for skins and other special equipment for they use it in automation. Basically, programming microcontrollers in C language. Next, I moved to utility in the transmission of power electricity in the network of Brazil since 1998 up to now. I have 25 years of work in this field. And when I came to that utility, I was very surprised by the work people have been doing there. They have created a big system for monitoring control of the network grid that was a replacement of an old system they had that was bought from Leeds and Northrop, North American company, very old. But they tried to replace that system with another one, tried to buy another system. But in that time, the company couldn't afford to buy another system because it's too expensive. The people there created from nothing a distributed control system using DOS extended with multitasking, all created by them with mechanism of publish subscribe and redundancy and distributed processing, crazy stuff. I never seen something like that. I was amazed by the work people have done there. And that inspired me a lot. I thought that I wish that we someday I could create something like that, be something like this. But at that time, a little bit before I entered that job, people was retired with the object. At that time, the company was state-owned. they intended to privatize the company. Then they retired all the engineers from that project. Only one or two left that I had the opportunity to work with them. And then I learned a lot, even from people that are not there anymore, just by looking at the code and seeing what they have created. But at that time, what happened was that the power system was growing very fast. Basically, the country was developing very fast, and the power grid was basically doubling the size each 5, 6, 7 years. It was crazy, and what was happening, the digitalization was multiplying by 10 the number of points that was acquired from substations, and the system was growing in size absurdly, very fast. And we since then we are seeing that that system that people created would not last very much time. So we decided to buy another system to replace that, because we didn't have the manpower to port that system they created, because there are too few engineers left to do that. So the only option was to buy another system. We bought the system that was developed by CEPEL, a research facility in Brazil that had a lot of position in the transmission sector there. The most of the grid is controlled by that sole system in Brazil today. And it was a nice system in using up to now. And what was happening in that time, about 2005, 2008, was that in substations we have local HMIs that for doing local control of the substation. That HMI caused so much problem because they were closed source and provided by different manufacturers of each station have a different system, and systems had control dongles of licensing, and were difficult to replace and substitute and upgrade and give maintenance. There were always computers, substations were always times are failing, and the substation were frequently robbed. They take the computer from the substations, then you need to replace it, create another substation, install the system again. That was so much trouble that people in the company decided to ban this control HMIs from substation. There was not thought anymore, and decided to do out control from the substation panels. Next, what happened was in a few years, those control panels became so complex, so many interconnections, so many relays, and so many equipment and buttons and that became so expensive and complex that people decided, oh, we need the HMIs back. And I was experimenting with, I was building an experimental HMI to create small control centers.
And those were the two project links I'm imagining that you shared earlier.
Yeah.
Gotcha. Yeah.
Project OSHMI that was created to control local control of substations.
Yeah.
We use that since 2008, and now we have about more than 80 substations with that system. That we can control substations locally with that.
Yeah.
That project was very successful. People from other countries use that to control substations.
That's a very moving origin story, and I think the origin is equally as important as the quality of the open source project, and we'll get into that. But thank you, appreciate the introduction, and with that, we'll go ahead and kick it off to you, Haruna. If you just want to go ahead and tell us about how you came to be in manufacturing and some of the work that you're doing now, and we'll go from there.
Okay. My name is Haruna Umar. I studied electrical and electronics engineering in Nigeria. That's a 5 years program leading to a Bachelor of Engineering degree. So, after I graduated in the year 2015. After my first degree here in Nigeria, we used to do mandatory National Youth Service. I went for 1 year National Youth Service. Initially, I started as a teacher in high school. I taught science, mathematics, physics, and even computer science to high school students. I taught for a term, so then I left for a term. A term is 3 months, so I left. I got a transfer to a Ministry of Work. That is a state Ministry of Work, where they do projects, engineering projects, generally, including electrical engineering and what have you. So, I had a privilege to work in a computer, that is in computer design lab, that is computer aided design lab. So I was there in the ministry for up till when I completed my national youth service 1 year. So there they do electrical engineering work, they do design, generally state governments projects, engineering projects or infrastructural projects of states. It's been what do we call it? Carried out and managed by the Ministry of Work. So I was there for 1 year. I was learning how they do their work there. So after 1 year, I had a privilege. I was working with an engineer, or let's say a man who does installation work, electrical installation for buildings. So we used to install electrical systems for buildings, generally power supply system, electrical services for building, lighting, power points, power distribution, power, and including earthing systems. So I finished my mandatory national youth service, and in November 2017. So in 2018, I joined that company that does electrical services work. So I worked for like 2 years, up to 2 years. So personally, I also had an uncle who introduced me to in school. I had great passion for computing, networking. So and my uncle introduced me to web development. So I learned web development on my own. He gave me introduction to web design, web development, taught me. So he made me learn how general overview of web development. So I also learned about HTML. I learned about the functions of CSS, JavaScript. I also learned about PHP and SQL, but not in depth. Not in depth. So in 2019, I traveled to meet another uncle where he's an engineer, a power plant engineer. So I stayed with him. So he gave me a responsibility to teach in school. I also taught there. I taught sciences to high school students too. During that time, I also had a passion for power system engineering. I was developing myself in a lot of aspects of electrical engineering, including information technology, electronics, power system engineering, like that. I was developing myself. So in 2019, they advertised for job in Transmission Company of Nigeria.
And is that the
So
state-owned company that manages the
yes,
power grid?
yeah, yes. The history of electricity, the Nigerian electricity industry. Initially, we used to have NEPA. When I was born, I grew up to meet NEPA, the Nigerian Electricity Power Authority. One single company owned by the federal government was in charge of generation, transmission, distribution. Everything was owned by the government. So in 2015, they decided to name it a power holding company of Nigeria in preparation towards transition to the regulated market, to unbundle the industry. So they, what do we call it, incorporated the power holding company of Nigeria. So I think in 2014 or thereabout in 2015, they unbundled the industry into three. They privatized the whole generation sector and the distribution sectors. About 11 entities owned the distribution sector. So we had 11 what we call it, distribution companies that took over the distribution sector. Then we had different generating companies. While some few were federal government Nigerian Integrated Power Project (NIPP), partly that is owned by that is what we call owned by a separate entity, that is managed by a separate entity, though the ownership is still up for the government, but it is what we call it, managed by a separate entity, the Nigerian Integrated Power Project, which is it is managed by the Niger Delta Power Holding Company. And the transmission company was left unprivatized up to date. It's owned by the government. So, and the transmission company is in charge of managing the national grid. The National Control Center is under the management of the Transmission Company of Nigeria. So I while I was with my uncle in one of the generating station, hydroelectric generating station, I got information, they're inviting applications. So I applied, I wrote exam, I wrote interview. I was privileged. I got the job. So that was in late 2019. I got the job. So we resumed duty in the year 2020. So when I started, they said we need to go on 1 year pupillage, that is pupillage training, 1 year training. So I was posted to the National Control Center, Osogbo. There they have a substation, a transmission substation, and then they have the National Control Center. So they had the privilege to learn the power system engineering, that is transmission field services, substation operation and maintenance. So I have the privilege, I worked in various departments there. Mainly we had four to five departments. We had the protection control and metering department. We had the electrical maintenance department, the line maintenance department, and system operation. So I had a privilege. I did the rotation. I spent some time in each of the departments. So I had very good experience on how the jobs are done. In fact, I participated in doing the jobs. So I also had a privilege, since the National Control Center is there and is still owned by the transmission company, I was also posted there. I had a privilege to work in the control room where they do the operation of the national grid, coordination and operation of the national grid. I worked there. I also worked in some departments that support the operation of the grid. That is the SCADA department. Is in charge of operating and maintaining the SCADA system that is used for operating the grid. I also had a privilege in working at the communications department that is in charge of operating and maintaining the various communication equipment, including for the SCADA and even other communication systems like those used for telephony and what have you. So I had the privilege. That's where I encountered the RTU and various communication technology like the popular IEC 101, 103, and mainly 101 and 103. So I had an experience on the operation and maintenance. Every morning we go, we use the HMI there, the SCADA HMI there. We access the condition of the SCADA system, the various working RTUs, the ones that are faulty, we take necessary action. So I had the privilege to work there. So at the end of the year, we had a 1 month classroom work towards the end of the year. So after that, at the end of the training, we were dispatched. We went on annual leave, and we are finally posted. So I was posted to this region where I am now since 2021. So I've been working as a substation operator, but I still have contacts with the various parties involved in the operation of the national grid. Then personally, since before leaving university and after leaving university, I have passion for technology. I have passion for technology, information technology in particular, or anything that has to do with technology, electrical engineering. I'm highly passionate, even computing, highly passionate. I love programming. I love IT, computer networking, and what have you. So I have a personal culture of personal development. I read a lot to develop myself, acquire skill, acquire knowledge. So in 2020, I enrolled in a program on edx.org.
The giant online classroom course platform.
So I enrolled in a course by TU Delft, Technics University Delft in the Netherlands. So I enrolled in a course for a smart grid, power systems and smart grid. modeling. It was 2 courses. What did they call the first aspect? There was the general course and there was modeling aspect of the course. So in the general course, I had the privilege. I learned a lot of things about modern power systems. Learned about smart grid generally, concepts of smart grid, and what makes smart grid, and a lot of knowledge about power system generally. I had the privilege. So then, as I'm working here, since, like I said, I'm a shift worker, I continued my personal development. I learned things like the IC61E50 that is used for substation automation, a lot of application, grid modernization, software. I also delve into like Python programming. I learned Python programming. I consolidated my programming skills in C language and C++. So I delve into Python development. I delve into software development. Like I am presently a Scrum Master. I did a course Scrum. So I am presently a Scrum Master. I have a certificate in Scrum Master. Then I enrolled in a course on Coursera by IBM, IBM software engineering and DevOps. So I acquired some skills about software engineering and modern practices like DevOps, various types of software development, like the monolith microservices, and software service-oriented architecture. I learned about those things. So, I still continue. Also, I have interest in machine learning and AI. Presently, I've learned about regression, linear regression, and what do they call the other aspect that is used to classification, regression classification. I also learn about neural networks and deep learning. There is this man, Enri from Stanford. So I enrolled in his courses. So I learned about linear regression and classification. I also learned about neural networks and deep learning. So but presently, my personal project, I intend to develop an application or a system that could be integrated with the energy management system or SCADA system that will be used for anomaly detection. That is based on system condition, an AI-based system for anomaly detection. Power system. Maybe it will be integrated as part of the energy management system. So my intention is to develop a software that will use artificial intelligence to detect anomaly and then come up with a solution to advise the operator or to take some action. You understand? To take some action to mitigate the effects or impact of the problem on the system. So, though I have not delved into it, it's a concept. It's a concept. So I also have some other small, personal proposals. So those are that's presently my focus is how I could develop a software or a component of the energy management system that will use AI to detect anomaly in the whole of the system based on the condition of the grid and available data to detect anomaly and then to far possible solutions and even if possible take action to mitigate maybe the effect or impact of that anomaly on the system. So that is my, the concepts I came up since last year, I just developed some sketchy, what we call it, write-ups about it, but I'm not actually moved in to actually start something about it. So that's my current status. And like I told you, okay. Anyway, yeah, I think I told you last time we met that presently the SCADA system we are using is presently that is in service that I learned about SCADA is the Siemens Spectrum 4 that was installed back in 2015 or thereabout. No, earlier than then. So the system is that is obsolete, of age, and quite a lot of things are no more working. So they decided to start a new project. They are currently installing equipment all around the grid. Then, so they will replace the SCADA system with a new SCADA system from NARI. So I am not active in the project, but I am close to people who are participating in the project, people who are part of the project. I get some information about the project. So the project is in progress. That's the condition of our system now. I can say that is a little about myself for now.
Yeah, thank you for that. There's a lot to be able to jump off of, and I think the perfect next step is actually two things. Number one, Ricardo, I don't believe I asked, but the power and distribution systems in Brazil, is that also state operated, or is it privatized to a similar extent like we have here in the US?
Yeah. Here we had a similar process that happened in Nigeria, because it was initially basically state-owned, but this process happened here much earlier than Nigeria. In the 90s, and afterwards, distribution basically was all privatized in the 90s, and generation transmission was kept state-owned about 70% two years ago, when the big Electrobras company that had that share of 70% of the market in transmission and generation was privatized. The state has kept shares from these companies, but not the majority. So there are now private companies, and very few state-owned companies have a name. Basically, two big ones that act in regional states, doing generation, transmission, and distribution. All the rest was now privatized. There is a system operation, independent systems operation that do the coordination, that is not private and not state-owned, strange entity that do the coordination of the system.
Yeah, it's definitely has its caveats on, how stakeholders are engaged and how improvements are carried out. One thing I did want to ask you, Ricardo, I know Haruna mentioned he essentially has, he's had a path carved for him before in some way by having family members pave the road to manufacturing. And I'm curious if, in your experience, Ricardo, if you had family members that were in manufacturing to some degree, or if you chose to enter the profession on your own accord.
No, no, I had no close friends, parents, and relatives that work in the business. That was my thing only. Yeah.
Yeah.
My decision to enter this sector.
It's funny how that works sometimes, right? You have two
That,
people.
that in the company I worked many times that happening. Fathers then to the sons the same position sometimes.
Yeah, it can certainly make it easier. I think it's fascinating though that two people who had completely different upbringings are still landing at the same path, right? Both are involved in power systems, albeit from several different aspects, where you're focused primarily on the software development and systems integration. And then from Haruna's perspective, he has really worked as the OEM side, the repair side, and the end user side. So I think there's very good sort of balance on perspectives there to see
Yeah.
what sort of challenges come up. And this is a great segue, I think, into asking you both on really what open source means to you and your current understanding. And Haruna, I think I'd like to kick this off to you because you brought up some really great points on the path to self-education, the ability to essentially control your own destiny and learn skills as you see fit, not only for what you have an interest in, but for what you are seeing on the front lines as a need in the, in your case, power distribution environment. So just really love to hear your thoughts on what your current understanding is of this phrase, of this sort of magical term called open sources, and what your thoughts on it are. And then we'll kick it off to you, Ricardo.
Okay, right. Actually, I prepare a little write-up here, kind of little write-up to explain some of my thoughts about open source.
Sure.
So I said the advent of digital and computer systems has brought significant progress in every aspect of human endeavors. This technology has most especially revolutionized industry and manufacturing. Industrial automation enabled by computer and digital technology has increased the efficiency and productivity of industrial processes and still hold a strong promise for a brighter future. As for we, the humans, we need to get involved in many fronts, ranging from design and development, deployment, and utilization of these systems as digital and computer systems. This requires companies, individuals, and organizations to invest in development, in deployment, and training of their workforce to take advantage of this great revolution. The competition and race is on. Adoption and deployment of these novel technologies may mean an interface between staying in business or being overtaken by competition. Technologies available today, especially software systems, are probably classified as closed systems, closed source, which are developed by companies and made available for sale to any entity willing to purchase, and open source, which are developed by individuals or groups not identified as companies. So my definition of open source is software systems that are developed by individuals or groups not identified as companies and made available for use for anybody that is willing or that needs to use. Open source solutions is a rapidly growing practice that is revolutionizing the software industry, where a given software can be developed by a person or group of persons in one part of the world, and a different unknown person from another part of the world can make contributions to the development of the app or use the app with or without the consent of the initial developer. However, some of the techniques and practices used in the open source practice, like collaborative software development, being adopted and used by the closed source manufacturers. One major challenge with closed source is that, unlike the open source, it does not offer the user the opportunity to make modifications, contributions, or adapt the app to suit his or her personal desire. However, this issue is not much of a problem because most closed source manufacturers have practices like Scrum, by which they involve the user in the development, deployment, and utilization phase of the solution lifecycle. There are also issues with risks of plagiarism and tampering with the integrity and quality of the solution. Furthermore, it should be noted that companies who are manufacturers of these products or solutions are also strongly involved and much aware of the various needs of potential users of their products. Manufacturers are part of industry consortia and carry out significant R&D, which make them have the knowledge of the needs of its customers. They offer continued support and updates routinely to make new features available for customers. They may even offer a room for the user to make some contributions. Finally, it must be stated that the open source practice is of great benefit in that it offers quick access to ready-to-use solutions to a vast majority of users and involve more contributors through its numerous solutions. Through its numerous solutions have been made available for use by proprietary and non-proprietary users. So that's my little write-up about the open source and closed source, what do we call it, terms.
It's interesting. There's definitely a divide, I think, for some people to want to look at it as a application just for software. And I think, we'll dive into that a little bit. But something I'd really love to hear from you, Ricardo, on the open source front is one of the options, or one of the things Haruna mentioned is the fear there might be on not only intellectual property, but that the tooling in and of itself, regardless if it's an open source hardware or software solution, is somehow inferior or more security and risk prone. And I have some thoughts about that, certainly. My general consensus is that it is broadly not the case, that there are more risks in open than closed source. And the stance I have on that overall is both will have issues. At least with open, you can see and verify for yourself at any time, and there is no need for any sort of censorship. But I'd really love to hear sort of your thoughts on open source, Ricardo.
I hear much things about that. Sometimes people say that business should use closed source market solutions, not open source solutions, because open source solutions doesn't offer support or doesn't offer guarantees or inferior sometimes. All the things people say, but we know that not always the case, because there are many great open source solutions in various types of software applications. A majority is, in most cases, better than proprietary solutions and more secure, generally faster to spot problems. I have seen that many times. Closed source solutions, often we see that they are discontinued, like happened in Nigeria, power control grid. That software you mentioned, Haruna. I have seen that happen so many times here with products that were discontinued, software, HMIs, SCADA systems. Frequently happened buyouts occurred from small companies, from big companies buying small companies, and what they generally do is they sell all the software and products they buy to third world nations, and after that they discontinue the product. Shortly after that, they discontinue those products. We end up with that waste we've happened many times. Also, maintenance sometimes difficult to do. We have to prove that there is a problem. When you prove there's a problem, they get the proof and send to developers. And years after that, maybe you have some solution. But most time, mostly of the time, most times, we don't have a solution. We have in Brazil two companies that provide solutions for basically all the SCADA market. In the power sector, we have two of them. There's two of them, Cepel and Ellipse software, that dominates the 95% of the market. And Ellipse dominates other SCADA markets like manufacturing, building information, oil and gas. They are just like more than 90% of those markets. And those local solutions, they being known in the market here, they provide better support and faster response to the clients than foreign software, big software companies. So they provided better solutions, but not as good as if it was open source, of course. Other problem I see that have big systems, expensive systems. You have to buy a system. Probably you will not have the opportunity to test the system in production without buying the product. At least you have to, like the case of Haruna, you have to buy the Enri system to implement it and put it in production, deploying and see that it works okay. But they don't have the opportunity to do a real test in scale. But with open source, you can do that without so much cost, less risks, I think.
Yeah, absolutely. I think for especially a critical environment like power generation and power distribution, it makes zero sense to force, especially in a state operated environment where the stakeholder essentially has to front a entire risk, and the vendor ultimately gets the entire benefit, because whether or not it works, they still got everything up front, and whether the users have feedback afterwards, it does not matter. It's already in place, licenses have been procured, and whether or not you implement or configure as you need, they are already out of there. And even in environments that are state operated, there's this perception that people believe with closed source there will be infinite support and it will never be an issue that you run out of people to rely on for help and ask questions. And clearly that is demonstrated to be completely wrong. It's just false. And we have two perfect examples here in two completely different countries that have the same exact issue. And I think
Yeah.
fundamentally it shows that there is a lack of stakeholder engagement at every level when you talk about closed source overall, and especially for critical infrastructure. It just, in my eyes, does not make any sort of sense to even use closed source, period, in such important environments. There's just too much at stake. There are far too many stakeholders, and it makes no sense to take the risk all up front and receive no payout whatsoever. So I think you bring up a good point, Ricardo, and something I'd really like your feedback on, Haruna, is when it came to getting trained on some of these control systems. What was that like for you? Did you actually have the ability, if you wanted to, uh, completely aside from the process when you were applying for a job, right? Did you ever actually have the ability to utilize any of these systems beforehand so that you could, for yourself, see what it was like so that you could help train yourself? Since you're a big proponent of, open education, I would imagine that's one of the first things you went to, right? Which is, I wonder if I can get my hands on this so I can learn on it, about it on my own, and then continue to expand that knowledge on the job. I'm just curious to hear if you were able to actually do that. And if not, I would love to hear your frustrations on it, because I know personally there's been many a times there's a system I've been expected to just know, when the only way anybody could ever actually get their hands on it is if you cough up millions of dollars to be a subscribed user to that system. And it's a very small and special club. So I'll kick it off to you, Haruna, on that regard.
Yeah. Here in Nigeria, we have a department called SCADA that is in charge of managing the SCADA system, operating and maintaining it. If there's any problem, what we do, the existing SCADA system is that is when we, based on what I was told, when we still had a support agreement with Siemens. If there's any issue that need deep technical, what do we call it, intervention. Though it was actually due to the kind of agreement that was meant initially in the first stage when the SCADA system was procured and installed.
Mm-hmm. But
It
you
did
as
not
a
include,
user though, before
yes,
getting on the job, did
yes,
you ever actually have the opportunity to learn what the SCADA system was going to be, so that as a employee, but also as a curious engineer like you are, did you ever actually have the ability to get fully hands-on with the system prior to actually landing a job so that you could understand and know what it was like?
yeah, yeah. On personal note, I had a certification before I joined. I had a certification on programming logic controllers and general knowledge of industrial automation. It was one of my area of personal development. I learned quite a lot about industrial automation. I learned about programmable logic controllers. I learned about distributed control system, the HMI for general industries.
Right, for general, not for
for
Siemens.
general,
Yes.
not for electricity industry.
Yes, and that's essentially the problem that Ricardo and I think you two would acknowledge. You know, those
Yes,
general principles apply universally. Uh,
yes,
well, you would imagine at least, but it's not the case. And I'm sure you can attest to this, Haruna, where how something should be done as a best practice in the profession and how it's actually carried out via the vendor's level of support for the system, as well as how the system overall functions, are completely different. And the argument I'm making is that makes zero logical, rational sense whatsoever. You have highly technical staff. It should follow suit that for a highly important and critical environment, the same best practices carry over to your software and hardware systems, period. It just doesn't make any sense to deviate from that otherwise. And to not have the ability to get any sort of access on it independently, to self-teach, and more importantly, I think, as you mentioned, Haruna, to be able to critique, to be able to independently think and critically do so without the need for somebody else telling you how to think and how to do it, is very important. Very, very important. It's the fundamental backbone of what makes open source, not only software projects, so helpful, but the whole concept around knowledge sharing and the inherent right to get access to information. Very, very, very important. Without equal access to information, there can only be equal susceptibility to being a victim, because there's going to be actors that will take advantage of that. And the only way to combat that is equal access to knowledge. And I think fundamentally that is what, in my eyes, open source means. The ability to control your own destiny and the inherent right to share knowledge and have access to that knowledge, regardless of whether you're a private owned company that's doing contracts for the government or if it's a state owned entity that is executing various functions for society at large. At the end of the day, I personally don't believe in centralized access to information, and we see models of that in society at large, whether it be state-owned functions, whether it be contractors who then create conglomerations or consortiums, like some of you were mentioning on industry consortiums for, in this case, power. Those are essentially special interest groups that are lobbying to limit knowledge in order to sell their services for a price, and it's just not good practice. The scientific profession overall calls for critical thinking and really beating an idea to death because it's the only way we can get to a common level of understanding. Um, One of the things that I really wanted to kick off next is, there's so much more that we could really chew on here, but I just wanted to hear from both of you, and I'll start off with you, Ricardo, on some of the potential avenues you see for, in your case, power generation and power distribution for open source projects and technologies to really fit a need that today is not being addressed. I know we talked about very briefly failover systems, and I know to some degree we have that for hardware systems, but would love to hear your thoughts on some other opportunities for open source to fit a need, and what a failover framework would be for the software and application side for critical infrastructure.
Well, I have seen comments in your posts that there are no options for SCADA control systems in open source, but there are. But don't know for each type of application if they are really capable of providing the solution people are needing, because that requires special knowledge of the sector, the manufacturing, that I don't have that experience. I have experience only in the power sector. I see that a lot of options in open source SCADA system, not a lot, but some interesting options, like SCADA LTS, that is a system that was derived from a Brazilian SCADA BR, an interesting system. Frangotin Fuchs has a nice UI and interactive web UI, very nice, interesting system for small projects and Modbus applications. I think it's good. There is Node-RED, of course, that is capable of doing many things, very flexible system. OpenSCADA, RedSCADA, I don't know very much. There are mine projects, all SGMI and JSON SCADA, that address the power sector. With JSON SCADA, I intend to do it, to make it usable by the manufacturing sector in oil and gas by integrating those PLC protocols that I don't have much experience, but I intend to integrate the PLC4X. That is a solution for integrating PLC protocols. With that, I think that JSON SCADA can be a good option also for manufacturing sector. I see that the IoT sector is already very good option, has already very good options in with a lot of projects from the Apache Foundation and the Eclipse Foundation. Very good projects. I don't think the need for IoT, there is a need for anymore for closed source solution. It's very, very good options already there. But for the SCADA and control system, here there is lacking better options. But we need to support the projects and make it support only the open source, because this is a lot of waste of resources not supporting open source solution. Other thing that is I think that is very good now is protocol stack. For open source protocol stacks are very, very high quality. Almost all protocols are supported by the open source solutions. I don't have any problem with that. I integrated a lot of those projects that people developed for various protocols in various languages and very high quality. And then there is AI. AI is being put out in open source. Very nice solutions in open source. I think that AI will be the great driver for the adoption of SCADA in the future, the near future, because AI will help you to integrate products and applications very, very, very easily and fast, and that will be much more easy to do with open source solutions. Because when you have open source solutions, the AI will be able to see inside the code of the solution and be able to propose modifications. suggesting solutions that will be very difficult to do with closed source. That will be a great driver for the adoption of open source solutions in SCADA in the near future.
Thank you. Yeah. I think Haruna has left the room. I was going to bring up a question to him. Yeah. We'll just... there we go. Oh. There we go.
Muted.
Go ahead and just unmute your mic.
You're muted.
There you go. I was just gonna ask you, Haruna, sort of as a wrap up overall, in your experience with power distribution. We were just talking about this a little earlier. There are not only brownouts, but there can be blackouts. And I think you probably have seen several solutions for hardware brownouts. You can have various forms like battery operated hardware systems. What I'm more curious to hear from you though is when it comes to failovers. We just so I'll just sort of go on this rant, but hardware failovers honestly have been around, and I'll get back to you in Haruna in just a second. But hardware failovers have been around for a very long time. It's frankly not all that difficult to do, and it's so much. We've done it so damn well, in fact, that many hardware backup solutions for consumer and industrial scale are very standardized, very affordable, and more or less everybody knows how to do it. The problem I have is there's no real framework that, number one, is open source, but even on the closed source side, number two, that does failover effectively for applications and specifically for embedded systems applications. So just like you have data generated in if you're a web SaaS company that's providing a solution like Tulip, for example, you have failover. You have applications that generate data. The state last known of that application in a failover environment would be such that when you bring up your system, in this case a hardware system, back up to speed, the application would not understand that an issue had occurred. It would know automatically its last state, the last stream of data. It would be able to pick up instantaneously. The work that the hardware was doing previously would also be as if nothing had happened. It would pick up. If it was doing some sort of transformation, it would make it seem like it's right back to the transformation. If there was a need for a ramp up, it would be able to simulate that ramp up so that your hardware would not be any wiser that it had failed and some new hardware had taken over. And similarly, your applications would not understand or have a need to know that there was a ramp up and a cooldown period, whatever the state might have been, to occur. And I would love to hear, Haruna, if you've actually seen such a solution for the application and software side, because I'm sure you've seen many hardware backup solutions. They are a dime a dozen, but when it comes to the application side, the control system side for failover, would love to hear your thoughts on that. Go ahead and just unmute yourself. There you go.
So yeah, specifically, the kind of system we have Taken from what we have in our SCADA system in the national grid. We have a system for, what do we call it? Backup, that is like failover system. But it's like a network system that is two separate systems having like similar kind of configuration and components, like system units, two
for
separate system
backup,
units.
you mean just the physical backup, right? We're not talking.
Yeah,
Yeah. So
the hardware and software.
when one of those systems fails, for example, what's it
Yes.
like for changeover currently for you, and to be able to restart? Obviously, that one has failed, and if there's a backup, the backup kicks on. But let's say both fail. Let's say both fail, but you have a hot swap for some other physical backup ready to go. What's your experience been like on the application side? Because ramping up a physical machine, there's many standard ways, and it's very well known how to do. But on the application and data side, what's your experience been like for failover?
Honestly, I have not seen a different solution other than what we have. If an application fails in this situation, it will go, the system is gone. So no, no extra solution.
Yes, that is the solution. Everything fails. Yeah. And I mean, we're talking, I know we are joking here, but we're talking about critical infrastructure. Electricity
Yes.
generation and distribution has been around for much longer than all of our age years put together. It's not something that
Yes.
is unknown, right? Even when I was going to university, within the first year, we immediately got training on power systems, from basic principles all the way to the maths, and even some hands-on training for failover systems. So it always baffled me. We knew so much. We have so much knowledge and expertise, yet on failovers of hardware systems. And it's not like we don't know how to make those hardware systems operate. So why is there such a complete lack of solutions for application failover, especially in critical infrastructure? And now take that same problem, but say you want to go on an endeavor like the projects that have been done in nuclear power plants. That problem is escalated even further. And so it's baffling to me, because fundamentally, component wise, they're using more or less the same hardware systems. So, which means a lot of those hardware systems, in terms of power generation, are executing very similar activities within similar process parameters. So one would imagine that some sort of SCADA application failover system has been implemented and hopefully created open source. It's not been the case, not only for open source, but for closed source. And it's quite baffling. That's ultimately what I wanted to get down to. It's very scary that is the answer.
But I think there is a solution.
There's Ovation. Ovation is one as a closed source. I'm not sure if you've used it, but Ovation is one.
I've heard of Siemens have something like MindSphere, a cloud-based solution.
Yes.
In which your application can run on the cloud. So maybe if what you have on premises fails, you have a backup on the cloud. If you have your system well integrated, with the internet, your MindSphere can serve, your application sitting in your MindSphere can serve as failover, though that will come with additional costs.
Yes. And for critical, the argument I'm making is there should be a local first approach, right? Because it just makes sense. Whereas, distributed data architecture systems is seen as auxiliary.
Solution for that.
Yes, go ahead,
I have
Ricardo.
a solution for that.
Yes.
Can I say something? When as a developer of SCADA, creator of the SCADA solution, I have experience in that. When I created OS HMI, I came to the conclusion that the difficult part of developing a SCADA is failover data synchronization. That is the hard part, the hardest part for sure.
Yep.
Everything else is just easy to do, but the hard part is synchronization and failover. Then I realized that when I was doing postgraduate study in big data and data science, I come across some database products like Redis, MongoDB, and other tools that I had the idea that one of these database could be the base of the core of the SCADA system, because those database already has solved that problem for you.
Absolutely.
Redis and MongoDB, at least I know that those two have solved that problem. So if that could do process near real-time data efficiently, could be a solution for the failover and data synchronization. And I decided to test MongoDB for that type of application, and came to the conclusion that it's a good solution for that. I tested MongoDB in various scenarios, and we putting some load in that, the system can give good responses even when heavily loaded, near real-time capability. So I decided to create JSON SCADA from zero, using MongoDB as the solution for data synchronization and failover. That was very successful. It was amazing, the result, because with MongoDB, you can have any number of computers from 3 on to have the failover managed by the database. And the application can run in the same nodes or in other nodes, and we will have the same capability for failover as the underlying database. And MongoDB has very flexible architecture. You can design a very flexible architecture for your needs. You can even create multi-region cloud solution as a backup for your local solution. So that can solve the problem you mentioned, the local first and cloud as a backup, or you can do any combination of that the solution requires, all in the cloud, multi-region, local in multi-cloud, any combination of that. All by designing MongoDB architecture. And the application sits outside of that, can be on the same nodes or in other nodes, no problem. That is amazing. You can have what you want easily and customize as you want. Use providers, manage providers, or host it yourself. No problem. That's a very, very nice solution for the failover mechanism. And what was left for me to develop was implement protocol libraries, drivers, and UI. The hard part solved by the database. I think that Redis can be a nice solution too, and even Postgres can be can do this job, I think.
Yeah, absolutely. That's ultimately an answer I was looking for. The issue of data persistence and synchronization is a topic that has been very well addressed by various database technologies, depending on what the use case is. And so there's quite a opportunity, I think, then to take the same functionality of data persistence, consistency, and synchronization to build out a framework for application building, so that that capability is easily allows you to easily deploy some custom need for your manufacturing environment. That's
this way it's already solved for you. You don't need to implement that.
Yes. Yeah. Absolutely. Yep. All right. We'll just go ahead and jump into the sort of finishing points here. I think there's been a lot of ground that we've covered, and this stuff, there's never enough time to cover it all. We can always off the bat, there's so many other topics that I was just thinking about going on and making more videos on, but what I wanted to do next is just sort of wrap up things, and number one, share where people can find you. So for those that are interested in connecting with Ricardo, his LinkedIn profile, as well as the links for the two GitHub projects he has, JSON SCADA, and as well as OSHMI. I will have those links in the description. And similarly for Haruna, you can find where he is via the LinkedIn URL I have in the description. With that being said, I checked really quick to see if there was any comments. You do have some praise by a gentleman named Tosin saying hello, Haruna. So say hello to Tosin. They're saying hello to you. And with that, just want to wrap up and get any final takes either you may have on the sort of state of manufacturing and your thoughts overall on open source. And we'll go ahead with you first, Haruna.
Okay. I'm sorry?
Just to wrap up, any words that you might have for people on manufacturing overall, and your take on the future of open source.
Okay, so like I said, open source practice is of great benefit. In fact, it has revolutionized the software industry, because you have access to numerous solutions that without it will cost you millions and billions to access. But on a click of a button, you can access quite a lot of solutions that are open source. So open source have made it easy for developers and users of software, applications, and solutions to do whatever they want to do. I've come across, in fact, virtually every solution these days, there is an open source for it. And in fact, open source have gone beyond that developed by individuals alone, even companies too, do open source. Like I was looking at Kubernetes, for instance. Kubernetes was actually developed by Microsoft, right? Oh, no, Google.
Google. Yep. Google platform.
Yeah, Google platform, but it's an open source application. So the open source world is that has brought numerous advantages to various aspects of human endeavor. If you go to GitHub, for instance, there are millions and billions of solutions there. You can always fork and do whatever you want to do with it. So the open source is of great benefit and of great use. Then finally, I would like to see that the the industry in a whole, or as a whole, digital transformation, digital technology is of great advantage and benefit. Whatever you are doing, try to find a way in which you can make use of computer or digital technology to enhance your solution, to enhance the productivity of whatever you are doing. There are many solutions out there, and you can also develop yours to solve your problem. So, in fact, even the most even there are some things you may think that you cannot do with technology, like the digital technology, but you can always find a solution using to use digital systems to solve your problem. I think that is what I have. That's my thought. There are many solutions, and one can always lay on different solutions to solve your problem.
Appreciate it.
And I must say, I'm grateful for this opportunity to meet this senior, let's say, senior men in the industry that I am learning quite a lot from, and I still have opportunity to learn from in the future. So I look forward to keeping in touch and to acquiring more knowledge and getting more opportunity to solve problems in the future.
Thanks, Haruna. Any parting words, Ricardo?
Yeah, I am 58 now. I had the opportunity to see the whole transformation of the OT sector since the 90s, and earlier than that, and up to now. It's amazing what we have accomplished. And in that era, we have even hardware customized, dedicated to the OT sector. It's not commodity hardware we have now. The network solutions, equipment were all dedicated, customized for the OT sector. So what we have now, we access to source code to many solutions. We don't even thought about that in that era. The concept of open source was not created at that time. Just at the end of the 90s, that Richard Stallman came about with the open source concept. After that, the evolution was incredible. What we have now, even AI in open source, is amazing. We have all the tools we need to create solutions and collaborate and develop easily any type of solution. So we had in those era many engineers that can do amazing things, but they don't have the tools we have now. Now, when we have the tools, we will not have the engineers to create things. And we are sure we have. No need for closed source solutions anymore for most applications. So I encourage people to try the open source products and criticize and blame if they don't find it good. Because I, being a developer myself, was moved by critics and the blames all the time. That's not a problem. And try the projects, and collaborate, make contributions in critics when need for features that were missing. Then developers can know that those features are needed by people. So interact with the projects, even if they're not capable of providing the solution you need now. Maybe in the future it can. So I encourage people to investigate solutions and interact with the maintainers of the storage. That's my recommendation.
Thank you, Ricardo. Appreciate both of your time. And for me, the biggest takeaway of all this, I think, is it's always fascinating how two people with completely different circumstances and upbringing can still find themselves to be on a very similar path and share many of the same needs, and to have those needs still to this day be very largely unmet, but to be in a time where they have the opportunity to figure out how they might be able to create the solution and accommodation for those needs without having to expect it from somebody else. And I think ultimately that's a very beautiful thing. Being able to have control over your own destiny, over your own life, even if it's a small modicum of control relative to everything else, I would still always prefer to have than to not. So with that, appreciate both your times. Thanks everybody for watching today, and we'll see you on the next one.